Next, we are going to hear a bit about cooler roadways. The faculty advisor for this project is Professor Charles-Guzman, and we will hear tonight from Jillian Yuting. So Jillian, I think you are still on mute.
Hi, sorry, can you hear me now?
Yes, I can.
Okay, great. Can you see my screen?
Yep.
Thank you.
If you advance one slide, just make sure that it's, yep, great.
Okay, great, thank you.
Sure.
Good evening, everyone. My name is Jillian, and I'll be giving the final presentation for my capstone group and our project on advancing the installation of cooler roadways. Today, I will cover the problem that we are addressing, introduce our client, our project approach, and explain the tool that we have developed. The main problem our group is addressing is the urban heat island effect. An urban heat island is a metropolitan area which is significantly warmer than its surroundings. As urban areas replace vegetation with infrastructure for growing populations, these surfaces absorb heat, causing an increase in surface temperatures and heat waves within cities. Furthermore, UHI has profound implications on equity. Low-income communities are often more likely to be in heavily urbanized, compact environments with little vegetation, resulting in low albedo and higher land surface temperatures. This leads to a greater need for air conditioning. As such, extreme urban heat disproportionately affects disadvantaged communities. They lack access to air conditioning, bear a disproportionate energy burden, and a high number of deaths caused by extreme heat. Studies on urban heat have highlighted a clear link between heat vulnerability, energy efficiency, and equity. Our client partner is the Global Cool Cities Alliance, also known as the GCCA. Their mission is to advance urban heat island mitigation strategies, as well as policies to reduce some of the warming effects of climate change through global cooling. Currently, GCCA is partnered with 19 cities who have indicated interest in implementing cooling solutions in their city. Based on metrics provided by these participants, over the next 10 years, there will be a demand for 24,800 lane miles with a financial investment of 2.25 billion in cool roadway solutions. For this project, the main type of cool pavement we are looking into is reflective coatings. This utilizes easy-to-apply surface treatment for new or existing pavements, particularly light-colored pigments and materials which can raise albedo. So albedo refers to the percentage of solar energy reflected by a surface, and most existing research on cool pavements focus on solar reflectance, which is the main determinant of maximum pavement surface temperature. As such, pavements with higher albedo can reduce the local surface temperature of a city. So to achieve our client's goal of facilitating the implementation of cool roadways, we developed a three-pronged approach. We first conducted research on the urban heat island effect, various cool pavement solutions, and international case studies. We also interviewed industry experts, such as GuardTop and Petrochem Materials Innovation. We went through several rounds of discussions and meetings with city governments and decided to work closely on the further development and implementation of our tool with two cities, San Antonio and Sacramento. We then developed our screening tool for city officials using GIS and quantitative analysis. Please feel free to ask us for more details at our Q&A at the end. So let me explain to you how our screening tool works. The first step of the tool is demonstration siting. This step helps city officials find out which areas in their city are in need of cool pavements. Users must first collect data about their city and input it into the weighted screening tool. The tool will then produce a choropath map that shows the highest priority areas within the city. It was very important to us that the scoring index for the tool and required data sets capture both the environmental and social dimensions of the urban heat problem. So we came up with two categories for our index: severity of UHI and social vulnerability. In order to assess the severity of UHI, we concluded that surface temperature and air quality will be the best heat indicators. We also wanted to account for vegetation cover and green density, so we decided to make NDVI a required data set as well. For social vulnerability, case studies globally all suggest that socioeconomic vulnerability is associated with UHI exposure, extreme heat morbidity, and mortality. So we agreed that poverty levels should be a required data set. Access to healthcare and services are also considered vulnerability factors for extreme heat episodes. Finally, studies have also shown that the elderly and children have an increased risk to heat mortality. So we thought age was an important determinant of vulnerability too. We have tested this step of the tool with data from San Antonio, Texas. Each census tract was scored based on the scoring index and ranked according to the legend on the right-hand side of the slide. From our discussions with city officials from San Antonio, we learned that there were specific council districts particularly keen and willing to implement a cool pavement pilot. We decided to take this into account as it will help narrow down the search for a demonstration site. So we only screened census tracts in these 3 districts outlined in blue, green, and red, and excluded the areas outside from the screening process. We will encourage other city officials to also take into account any other practical considerations that affect implementation. For example, if a city is prone to flooding, they could include information from the FEMA flood map. These practical considerations can help to track progress, identify potential success, and raise concerns. So the final output of this screening step is the choropleth map you see on the slide right now. The areas highlighted in red scored the highest according to our index and are most in need of cool pavement solutions. This step narrowed down potential pilot locations to about 2% of the total area considered. The data required for step 1 can be obtained from 4 main sources. The datasets required for UHI severity can be obtained from the USGS Landsat 8. Since June, July, and August are the hottest months of the year for US cities, the past 3 years of summer images can be used. The images should be filtered out to remove any images that had greater than 10% cloud coverage. This approach should yield a large enough sample of images to accurately assess conditions. For US Census data, the most up-to-date survey data should be used. And for data on social vulnerability to heat, that should be easily obtained from within the local government. The next step for cities officials would be to conduct site visits to the highlighted areas in the map to identify specific roads for pavement coatings. We recommend that they look at school parking lots, shopping areas, heavily trafficked sidewalks within these districts to refine their demonstration siting search. After this is completed, a cost-benefit analysis should be conducted to determine the potential impact of the pilot project. So the final step will be to select the exact area for a pilot project based on maximum net benefit. To measure the impacts of cool roadways for the city, several indicators can be used to assess its potential costs and benefits. We came to the conclusion that it would be useful to estimate the financial cost of the material, equipment, and labor, as well as savings from energy efficiency and amount of carbon emissions reduced. Reducing emissions and smog can also improve community health, urban equity, and standards of living for more vulnerable populations. In addition, increased pavement durability is a good potential benefit to measure, as a reduction in temperature of road pavements have been found to increase the pavement lifetimes, bringing about other economic and maintenance benefits too. So these are the results of the impact measurement for cool pavements in San Antonio. We looked at the heating and cooling degree days and the associated natural gas and electricity consumption for the past 3 years. For energy savings, we determined that there will be an annual net benefit of $11 million for every degree Fahrenheit reduced by cooler pavements. The benefit from a reduction in carbon emissions was found to be $1.5 million. And to estimate the impacts on health, we determined the annual number of days and person days where the EPA's ozone limit was exceeded. We then calculated the number of people with respiratory illnesses that were at risk due to the exceeded limit. We determined that reducing the air temperature of San Antonio by 5 degrees Fahrenheit will have an $11 billion benefit in terms of lives saved. In conclusion, We set out with the objective of helping partner cities identify the best location for cool pavement pilot project. And to meet this goal, we worked on a screening tool for demonstration siting and impact measurement. The findings from this tool should help city governments make an informed decision on where exactly in their city they should launch a pilot project and implement cool pavement solutions. Overall, we hope that this project will contribute to the long-term reduction of urban heat. We have managed to create a user-friendly and data-driven tool that can be used widely to encourage and facilitate the implementation of cool pavement solutions. This brings us to the end of my presentation. I would like to thank you so much for your time, and we would love to hear your questions and feedback. Thank you.
Thank you, Jillian. We do have one question in the chat from Ali.
Yep, hi, great presentation. I had a question about this. Why did you choose the cities that you did for your case studies? I think you said San Francisco.
Oh, no, so the cities we chose for our case study were actually Tokyo, Melbourne, and Singapore. So we delved into the best practices because these cities have extensive history with cool pavements. So for Tokyo, they have actually extensive implementation across their city, and the Japanese are extremely forward with technology. So we looked at them to see how the implementation and maintenance has been for cool pavement for solutions. And for Singapore, Singapore is still not at the phase where they have actually implemented cool pavements, but we looked at their case study because their future pilot projects are actually based on extensive research. So they've produced a primer detailing many cool city solutions, and cool pavements are one of them. So they've studied the various solutions possible and specifically why they advocate for cool pavements or cool roofs as well. So each case study for us was about understanding the different steps of a cool pavement implementation project from research to the final implementation. Yeah. I mentioned working with San Antonio and Sacramento because these are cities that have expressed interest in working on a cool pavement pilot project. And so we were actually having many discussions and meetings with them. And for specifically San Antonio, Texas, we obtained data from the city official, and that helped with the development of our tool because we used their data to trial and develop the screening tool as previously mentioned.
Okay, great. Thank you, Jillian. So next we have a question from Professor Unwin Kuraneri.
Great, thanks, Suzanne, and great job, Jillian. That was a really interesting presentation. You mentioned that there a figure of 2.25 billion for the 19 pilot cities, and I'm wondering, does GCCA or your toolkit provide any guidance to city on financing, or is that expected to come from them, or their suggestions of partnering with local bids or public-private partnerships potential for this?
So the financing for the pilot project is actually beyond the scope for our project. We're actually meant to develop the screening tool just to help the cities identify and look for the locations in their project. But I believe that the financing portion of the implementation of a pilot project will come definitely from GCCA side.
Great, thank you.
Okay, great. I am not seeing any other questions. Oh, sorry. One more question coming in from Casey Motley. Casey?
Hi,
You
thank
unmute
you so
yourself?
much. Yes, my question is, I saw that you guys looked at the effect of urban heat island on social vulnerability, but did you guys look at how it kind of pairs with slowing down traffic speeds in relation to safe streets, specifically in highly pedestrian areas or along bike paths?
Oh, that's very interesting. I don't think we actually considered that as part of our analysis of social vulnerability. But I think for us, that sounds like a rather specific consequence of UHI, but maybe we should look into it as well. Yeah, we mainly focused on the effects of heat on health and on health, because that was what most of our research seemed to focus on in terms of social vulnerability. But thank you for raising that.
Okay, great. Thanks, everyone. At this point, we're going to take a 5-minute break.